So when you do a squared plus b squared, you should have gotten square root of 10, square root of 10. Again, finding C, your 3 and 3 were both your legs. 3 square root of 2. Some of you may have gotten the square root of 18. Square root of 18, that is the simplified square root of 18, which is what we're going to be doing today. And then finding B, given your A and C, you should have gotten 5 square root of 3. Again, some of you may have gotten square root of 75. That means you just didn't simplify it. All right. Questions on those? Questions on those? Okay. The special right triangle. There are two triangles that are right triangles that create these ratios that always happen the same way. The first one we're going to talk about is called a 45, 45, 90. All right. So it is a right triangle. So we know at least that only one of the angles is 90 degrees. And the first one's a 45, 45, 90. They always had to add up to 180. Because I have two angles with the same measure, I have a special type of triangle. I have an isosceles triangle here. Remember, if my base angles are the same, then in this particular triangle, my side lengths are also the same. I automatically know that is an isosceles triangle because of those base angles being the same, okay? Which means if my side length here is S, my side length here must be S as well, correct? All right? So then how do I solve for my hypotenuse? Pythagorean theorem. Yes? Everybody agree? So if I want to solve for my hypotenuse here, I'm going to say a squared plus b squared equals my hypotenuse squared. Correct? Everybody see that? All right, so, well, what happens there? Well, I have a and b the same. So what happens when I add s squared and s squared? How many s squareds do I have?
2.
I have 2 s squareds equals c squared. I'm trying to solve for c. I have to take the square root of both sides. So I'm going to take the square root of both sides. It's going to be the square root of c squared. That's just going to give me my c. And then the square root of the other side. So what happens here on the other side? Well, the square root of 2 stays the same, right? I can't really do anything with it. What is the square root of s squared? Yes. So this is just s times the square root of 2. Because just like my process before, I have s squared. That's 2 s's. They pair up. It comes out. So my hypotenuse is going to be my side length times the square root of 2. This is a special right triangle. All 45, 45, 90 degree triangles will look like this. Your base lengths, your legs will be the same length. Whatever one is, the other one is. If this is x, this guy is x. And your hypotenuse will always be that side length times the square root of 2. Always. All right? Which means you don't ever have to do the Pythagorean theorem for this guy. As long as you know the side length, you can just multiply by square root of 2. That is your hypotenuse. If you know the hypotenuse, you can divide by the square root of 2. That is your side length, okay? You don't even have to do Pythagorean theorem here. You just have to know this. So you need to memorize these. 45, 45, 90. It is side length, side square root of 2, okay? This theorem says it, but it says it in all verbiage. If the length of a leg of an isosceles right triangle 45, 45, 90 is L, then the length of the hypotenuse is L squared root of 2. Lots of words. That means your side lengths are going to be the same. Your hypotenuse is the side length times the square root of 2. This is what you need to know for a 45, 45, 90 triangle. All right, so let's use it. Look at example 1. Find the exact values and decimal approximations for the lengths. Exact value means give me the radical form. Decimal approximation means plug it into your calculator and round it, okay? So you are going to be looking for those instructions when I give you a test or quiz. Exact means radical form. Round means plug it in, okay? So they have given me a 45, 45, 90 triangle. This is a side, this is a side, this is my hypotenuse, all right? They've given me the side length BC. So I already know that BC is 3 centimeters. They want me to find AC. If BC is 3 centimeters, how long is AC? 3 centimeters. And then they want the hypotenuse. The hypotenuse here is A to B. It is just going to be side length times the square root of 2 centimeters. That is my exact value. How do I find my rounded value? In your calculator, 3 times the square root of 2. Round to 1 decimal place, you're going to get, or should get, approximately 4.2 centimeters, okay? This is exact, this is rounded. All right, this is a little bit different. Which side of my right triangle did they give me? They gave me the hypotenuse, all right? Now, in this case, they said the word isosceles. They did not tell me it was a 45, 45, 90. That is the only type of isosceles right triangle you can have. So if they tell me it's an isosceles right triangle, they are saying 45, 45, 90. So I know these two are the same length. Now in this case, they gave me the hypotenuse, xy of 12 feet. My hypotenuse equals my side times what? Hypotenuse of this special right triangle equals side times what? We just said it. Square root of 2. All right? I am trying to find the side length. They gave me what this equals, so I am going to solve. They said the hypotenuse is 12. I know that that should be side square root of 2. How do I solve for side?
Divide by root 2.
Right, divide both sides by my root. It's going to cancel here. We're going to get that. Now, we just did a worksheet. It said never, ever, ever do what? Leave it in the denominator, okay? So if they want exact value and approximate value, you can find approximate value right here, okay? My rounded value in your calculator is going to look like this, 12 divided by the square root of 2, and you will get 8.5. But for exact value, you're going to have to do the rationalizing. All right, so we're going to take the 12 square root of 2, and we're going to multiply the top and bottom by that square root of 2, okay? On the top, we just have 12 square root of 2. On the bottom, what happens when I multiply square root of 2 times the square root of 2? What is it? 2. Can I simplify either outside numbers or inside numbers? Yes, my outside numbers can simplify. 12 and 2 simplify to what? 6 square root of 2. So these are my answers. This is my exact, this is my rounded, this is my exact answer. Okay? Rounded and exact. Questions on those? Simple enough? Yes. Is done with the concept of an isosceles triangle. And this guy's a little bit different. So we have an isosceles triangle here, which means that this side length is going to be our shortest side length. For this particular type of triangle, you do not have congruent side lengths because I'm talking about just this piece of it, just this piece of it. And so you end up having a little bit different. In this case, what happens, the hypotenuse actually is exactly double your shortest side length. So you're basing everything off your shortest side when you are talking about a 30, 60, 90 triangle. So your shortest side is always going to be the one opposite your 30 degrees, okay? Opposite your 30 degrees. Your hypotenuse, you should know that, that's your longest side, is always going to be double your shortest side. And your longer leg, which is this guy right here, is going to be your side times the square root of 3. This is actually also based on your Pythagorean theorem. It's also based on your Pythagorean theorem. And I'll show you why it works. So Pythagorean theorem here would say a squared, that's my s there potentially, so s squared, plus b squared, that's this guy right here, s square root of 3 squared. And that should equal my c squared, which is this guy, 2s squared. So we'll see if it works. S squared, well, that's just s squared. This, I square the s, so that's s squared. I square a square root of 3. I get just a 3. Here, I square the 2. 2 squared is 4. I square the s, that is s squared. I have 1 s squared plus 3 s squared equals 4s squared. That is true. And so that's what this theorem says at the bottom of page 319. It says if the length of the shorter leg of a 30, 60, 90 triangle is x, then the length of the longer leg is x squared root of 3, and the length of the hypotenuse is 2 times x. This is your second special right triangle, 30, 60, 90. So you will get a short side x, shorter leg here. The longer leg is going to be x squared root of 3. And the hypotenuse is going to be 2 times x. 2 times x. All right, any questions on that one? So let's use it with example 3. Example 3. All right. Find the exact value and decimal approximations for this. All right, exact value means I want the root to stay in there. All right. Decimal approximations, I'm going to plug it in. All right, so let's look at this first. This is my shortest side here, this x right here. That's my shortest side, which means my longer side should be my short side times the square root of 3, correct? And my hypotenuse should be 2 times my shortest side. They've only given me one side here. Which side did they give me? My longer leg. So they gave me this right here, and I am going to use that equation to solve for what my x is, to solve for that shorter leg. So my equation is my longer leg equals my shorter one times the square root of 3. To solve, I'm going to do exactly what I did before on example 2. I'm going to divide both sides by the square root of 3. All right? Over here, it's going to cancel. Remember here, I need to rationalize it. Multiply the top and bottom. So on the top, I have 12 square root of 3. On the bottom, remember, those cancel out the radicals, and I just have 3. Over here, I canceled it out. I just have x. I can reduce. What can I reduce? 12 and the 3. So this is going to be 4 square root of 3. That is the exact value of x. So the exact value of x is 4 square root of 3. All right. They want an exact value of y, of z rather. What is z? Z is 2 times x. I already found x. 2 times 4 square root of 3. How do I multiply those? I multiply what's not in the radical and what is in the radical, right? This is not in the radical. 2 times 4, that is 8. Square root of 3, there's nothing to multiply it by. So what I'm telling you here is don't distribute. People try to distribute here, and that's not what you're doing. Just multiply the outsides. So my exact value is 8 square root of 3. How would I get my rounded value for these two? I would plug them into the calculator. Plug in your 4 square root of 3. You're going to get approximately 6.9. It is centimeters. Plug in your 8 times the square root of 3. You're going to get approximately 13.9 centimeters there. All right, so exact value is the radical. Rounded value is the decimal. These are your answers here. All right.